Okay, we're going to be going over how to write a polynomial function when you're given a graph using x-intercepts. So first thing, we're going to identify a couple of things here. First, we notice that our degree, the degree. Now you'll notice that it crosses the x-axis at 2 points. So we know it's going to be second degree. We also can tell because it's a simple parabola. Sign of the leading term, we know it's got to be negative because starts going down, ends going down, is a negative parabola here. So we would, sign of our leading term would be negative. Now next thing we look for are the real zeros. So in order to do that, we identify where on the x-axis is this crossing. So if I'm looking here, I would notice I got 7. Over here I would notice I have 5. So my real zero options here are 5 and 7. So now it's asking us to write it in intercept form. So typically here's how we would write it. We would write it as y or f of x. We'll go with f of x, our output, equals. Now a is going to be our coefficient that we're going to multiply. And then it's always going to be x minus, and then x minus. And x minus, that represents whatever our real zeros are. So we have 5 here, that would be 5, and we've got 7. So we're almost done here. We just have to figure out what a is. That's that coefficient that we'd be multiplying here. Now we know it's going to be negative because it is pointing down. So in order to do that, we use the information that the graph gives us. You'll notice that we have a point here on our graph. 1, 1. No, it's not 1, 1, excuse me. That would be 6, 1. Glad I caught that. So what that represents is an x and a y, our output. So what I can do is I can plug those values into this function and see what I get, and that will give me a. So if you follow here, my output would be 1 or y. A, we don't know what a is, but we have an x value here of 6. So I'm going to plug in 6 for each of these. Now I just multiply it out. A times 6 minus 5 gives me 1. 6 minus 7 gives me negative 1. And over here we've got positive 1. Again, what I'm just doing is I'm just solving this. 1 times negative 1 gives me negative 1. So I get 1 equals negative 1 times a. I'm just going to shrink this down a little bit. Cool. And then divide each side by negative 1. And I get negative 1 equals a. So it's telling me my coefficient is going to be negative 1. So now that I've solved for a, I can replace it here with negative 1. So again, the trick is you want to find the x-intercepts, and then to find a, you just plug in the point that you have on your function. Now for standard form, all you got to do is multiply this out. F of x equals negative 1 times x minus 5 times x minus 7. I'm going to multiply it out. I'm going to start out by doing it this way. I'm going to go, you have a few options here. This is the way I'm opting to go. Positive 5, x minus 7, okay. Next step, boom, boom. So this would give me negative x squared plus 7x, because negative x times negative 7 gives me positive 7x, plus 5x. 5 times negative 7 gives me negative 35. I'm almost done here. Negative x squared plus, let's see, I forgot my x here. It's all right. So positive 7x plus 5x gives me 12x minus 35. So now I've solved it in standard form. And that's how you go about doing this. First, you identify leading term, sign the leading term that tells you what your coefficient is going to be, positive or negative. Identify your real zeros, just like I did. And then for intercept form, x minus the real zero. Again, we do the same thing again, x minus real 0. And then we establish a, that coefficient, which we don't know initially. And then we solve for a by just plugging in the point. Again, I went with that point because it was nice and clear. Plug in the point of your function. So in this case, I went with 0.61, so I used 6 for x, 1 for y. I went about solving, and that gave me my coefficient. And then for standard form, I just multiplied it out. Hopefully this will help you when you have to write polynomial functions from a graph.